Hello friends, in our previous video I have already discussed about the emitter follower or common collector circuit. Okay, so this is the general circuit. Across RE we are taking the output voltage, and basically across RE we are also taking these voltages, basically feedback voltage also for this input. So if you check my video playlist on the identification of the feedback topology, from there we can clearly say this is voltage series feedback topology. Why? Because from where we are taking the output, that node is basically the starting point of the feedback network, that is the emitter resistor. So this is voltage sampling, and to determine the input voltage of this NPN transistor, that is the base emitter voltage, we have to apply the KVL, that is Kirchhoff's voltage law, in the input loop. So that this is basically series mixing. So this is voltage series feedback topology. Now in our previous video I told you that is beta or feedback factor for this common collector amplifier is 1, and we know that is AF, that is overall gain with feedback, almost equal to what? 1 by beta. So basically overall gain also almost equal to 1 for the common collector feedback. Okay, so let us check is this statement is correct for practical simulation circuit. I proved theoretically that the overall gain for this common collector system is 1. In this video we will show that by Multisim. So let us check. See, this is the Multisim simulated version of the common collector amplifier. I have already made this circuit in Multisim. This is very simple. This is voltage divider biasing. These two capacitors are present, and this is basically coupling capacitor, and this source is basically small input voltage. Okay, now when we run the simulation mode, see what is happening. When we press the oscilloscope, it starts giving output, but before going to output, check carefully. The A terminal is basically the red wire, and that is the input, and B terminal is connected with the output, which is blue wire. So the red waveform for this case is basically the input waveform, and the blue waveform here basically is the output waveform. Now if I stop the simulation, see at any instant what is happening. If we place the cursor, see at any instant channel A, that is input, that is the red waveform's magnitude is 19.978 millivolt, and the output is that is channel B, the blue waveform is voltage is 19.608 millivolt. That means these two voltages are almost same. That means V output by V input is almost equal to 1. Check any other instant. See here, channel A's voltage is minus 19.666 millivolt, and channel B voltage is minus 19.319 millivolt. So at any instant, basically what is happening, the output voltage is almost equal to the input voltage. So basically for this case, due to application of the negative feedback that is applied by this emitter resistor, the overall gain of this system becomes unity. Okay, and see one thing, this is very important. In CC amplifier we have noticed that there is 180-degree phase shift in the output compared to input, but see here the input and output have no phase shift. Input is also starting from the positive half cycle. See, output is also starting from the positive half cycle. Okay, if you superimpose the output, see it is directly superimposed, exactly superimposed on the input. You cannot predict any difference in between input and output. Okay, so basically for common collector amplifier, the output follows the input. Okay, the output is almost equal to input, so the overall gain for common collector amplifier, that is for this circuit, is basically unity or 1 due to application of negative feedback. So this is the Multisim simulation of the common collector amplifier. This is all for this video. Thank you for watching.